So let's go the other way. Suppose we have some information and we're asked to find the equation of the ellipse. Let's look at number 56. They're telling us the center, then the vertex, and the foci. So let's draw a picture of what's going on. It always helps to draw a picture. So our center is at -3, 1. I'll put a C here for center. We have a vertex at -3, 3. And we have a focus at -3, 0. So we know this distance, right, from the center to the vertex. So that is a 2. And we also know the distance from the center to the focus, which is 1. Okay, so that's our C value. Now, we also know that this guy's going to open this way. So we know the format. So our format is going to be this guy right here. So let's write down everything we know. And then let's substitute in what we know. So we have a center at -3, 1. So this is going to be x minus -3. And this is going to be a y minus 1. We also know A. That's the distance from the center to the vertex, because this is one of those vertical ones, right? One of those tall ones. So A is going to be 2. We just got to figure out B. And remember, we have an equation that ties everything together. B squared equals A squared minus C squared. Our A is 2. Our C is 1. So that's going to be 3. So B is going to be the square root of 3. Remember, this is going to be the square root of 3 squared, which is just going to give us a 3. So there's the equation of that graph. 2 squared, and we could write 2 squared as 4. Let me just simplify that just a little bit more. All right, let's look at one more. Let's look at number 62. So we have a center at 1, 2, focus is at 1, 4, and it's going to contain the point 2, 2. So let's draw a picture of what we know. So the center is at 1, 2. I'll put a C here for center. Focus is at 1, 4. And we know the distance between those is 2. And the distance from the center to the focus is the C value. So we also know this thing is going to open tall. So we know the format again. So we have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So let's substitute in what we know. We know the center. So we need to figure out A and B, and we know C. We also know that b squared equals a squared minus c squared. Okay, but I've got too many unknowns here. So let's see if we can use the point. The point that they gave us in this one was 2, 2. So let's substitute that in and see where that gets us. So we're going to have 2 minus 1 squared over b squared plus 2 minus 2 squared over a squared is equal to 1. So this is going to be 1 over b squared plus 0 over a squared is equal to 1. Well, 0 over a squared is just 0. So we will have 1 over b squared is equal to 1. So 1 equals b squared. And if I take the square root, I'm going to get 1. Okay, remember, technically you have a plus or minus 1, but b is a distance, so we're just going to go with 1 there. And now that I know that, I can use this information. So I know 1 squared equals a squared minus c squared. Our c was 2. So 1 equals a squared plus 4. Minus 4. And then we're going to add 4 to both sides. So 5 equals a squared. So square root of 5 is equal to a. So we've got all this information. We can plug it in to this equation. So our equation is going to be x minus 1 squared over b squared, which is 1 squared, which is 1, plus y minus 2 squared over a squared. Square root of 5 squared is 5, and that's going to be equal to 1. So there's our equation for that graph. So let's do a word problem. Jim, standing at one focus of a whispering gallery, is 6 feet away from the wall. His friend is at the other focus, which is 100 feet away from him. What's the length of the whispering gallery, and how high is its elliptical ceiling at the center? So let's draw a picture of what's going on. And we're going to put this on the Cartesian plane, similar to what we did before. So we've got this ellipse. I'm going to draw it like that. Here's Jim. He is 6 feet away from the wall. Here's his friend, which is 100 feet away from him. And he's also going to be 6 feet away from the wall. The reason we know he's 6 feet is that Jim is standing at one focus and his friend is standing at the other focus. So the focus is always going to be the same distance from the vertex, which is here, to the focus. So that distance and that distance have to be the same. So the first part of the question is asking what's the total length of the gallery? Well, we've got 100 feet between them, plus 6 feet from Jim to the wall, plus 6 feet from his friend to the wall. So that's going to be 112 feet. And then they're asking us how high is the elliptical from the ceiling? So what is this distance here? So that's what we're going to figure out. Now, to do that, it'd be nice if we could take this and find the equation of this thing, right? So let's talk about what we know. We know the distance from here to here, right? From the center to the vertex. If this total distance is 112, then this distance from the center to the vertex, which is going to be A, is 56. So we know A is 56. C is going to be the distance from the center to the focus. And we know that too, because there's 100 feet between the two people, then the distance from the center out would be 50. So we know B squared equals A squared minus C squared. So we have 56 squared minus 50 squared, which is 636. So B is going to be the square root of that. And I got about 25.2. So B, and that's that distance along that minor axis right here, is going to be about 25.2 feet. If we wanted the equation, it would be x squared over 56 squared plus y squared over the square root of 636 squared is equal to 1.